Okay, so this is the third part of the algebra lesson series, right? So in today's lesson, we will first look at some different types of functions and their graphs, right? So first, the simplest function, constant function. So a function of this form, fx equals some constant, fx equals k, where k is a constant, is called what? A constant function. So examples are fx equals 5, gx equals minus half. So any function of this form, if a function equals some constant value, that is called a constant function. So for any x value, the y value is always going to be 5, no, in this one. And for the second function, for any x value I input, y values are always minus half. That is why it's called constant function. So y value is constant throughout, no. So that is why the graph of a constant function is what? A horizontal line through k. So for example, if I want to draw these two graphs, fx and gx, fx is going to be what? A horizontal line through 5. So this is fx equals 5. Then this is what? This is going through minus half. So this is gx equals minus half. So that's the first type of function we learn. So that's constant function. Now the next type is linear function. Linear function is a line. You have learned in O levels what is the equation of a line. Y equals mx plus c. Here instead of y we put f of x function. M is the same thing as you learn. M is the gradient. C is the y-intercept, right? So the graph looks like this with y-intercept, and this one is a positive gradient graph. If the gradient is negative, it will look like this. This one, m is negative. In this one, m is positive, right? So that is the second type of function, linear function. So linear function is a line. F equals mx plus c, right? Now the third type. This is called piecewise functions or piecewise defined functions, right? A piecewise functions are functions where the rule of the function changes for variable intervals of the domain. So unlike the previous ones, this one has several parts for the function. Each part is valid for a certain domain. Here look, this function fx has 3 parts. It's equal to x squared when the values of x are less than or equal to 0. The function equals x plus 2 when the values are between 0 and 2, including 2. Here drop the here it's going to be greater than 2. And the last part, it's equal to 5 when x values are greater than 2. So this type of function where you have more than one expression and more than one domain. What I mean by that is the domain is split into parts. Here the domain is split into 3 parts, and in each part you have a different expression, right? So this type of function is called a piecewise defined function, right? Okay, let's try to draw this one. So it will give you 3 shapes because it has 3 different expressions, no? In each region you will get a different shape for this question, right? So first let's start with the first region. First region is what? X less than or equal to 0, right? In that region, what is the shape? Fx is equal to what? Fx equals x squared. This is a shape This shape is called parabola through the origin, right? Fx equals x squared shape is this. Remember that. This is the shape for a function that has this form. Fx equals x squared has this shape, parabola. This is called parabola with the vertex at the origin. And it's going to be a symmetric shape, symmetric about y-axis, right? Then between 0 and 2, what is the shape? Fx equals what? Between 0 and 2, fx is what? X plus 2. This is what? Line with gradient 1, y-intercept 2. And finally, for any values greater than 2, what is the function? Fx equals 5, constant function, right? So now let's try to draw this. Right. So the important points you have to mark are 0 and 2, because at those points you break the function into different parts. So at x equals 0 and at x equals 2. So we'll mark those 2 points, 0, 1, 2. Right. So now x equals 0 belongs to the first part. Okay, so then let's find the function value at 0 first. F of 0, how would I find f of 0? To find f of 0, I have to substitute it into which one? I have to substitute into the first part, because x equals 0 belongs to that section. So f of 0 is going to be 0 squared root 0, right? So then let's mark it with a dot, colored dot, because it belongs to the x squared graph, right? Then I want to draw the x squared graph for the negative side. So this is the full graph, no? So I am only interested in the negative side. So I only have to draw this one. This is the full graph, but look at my domain. It's for the all the negative values of x. So I have to erase the positive side. Right. So that's done. So first part of the piecewise defined graph is done. Then the second part. Second part is a line. No? So we'll find what is the starting value. When x equals 0, what's the value? When x equals 0, this is going to be what? Starting at 2. So let's mark that somewhere here. So when x equals 2, but it doesn't belong to this section. No? 0 belongs to this section, first section. That is why there's a circle here. Then I will find another point, f of 1. 1 is in this region, this range. So I have to use the second expression to find the function value at 1. So what is that going to be? 1 plus 2, 3. Right. When 1, it's going to be somewhere here, 3. So now, and what is f of 2? F of 2 is what? F of 2 is 4. 2 plus 2, 4. Right. So somewhere here. Right. So then I have to mark from here to here And here look, f of 2 belongs to the second section. So the endpoint value I have to color a dot. Right. So now two sections are done. Now the last section. Last section is what? All the values greater than 2. That is what? Fx equals 5. So put a circle because it doesn't belong, because 2 belongs to the second section. Right. Then draw a horizontal line through 5. So this is the graph of this piecewise defined function. So it has 3 different shapes. Right. Okay. So now we know piecewise defined functions, and now for a piecewise defined function you should be able to find any function values. So let's say I want to find f of 100 for this piecewise defined function. Then which expression should I use? First part, second part, or third part? 100 is where? 100 is x is greater than 2. 100 is in that section. So I have to use this expression. So then f of 100 is what? 5. Let's say I want to find f of minus 2. Minus 2 is where? Not here, not here, in this section. So I have to use the first expression to find f of minus 2. So that is going to be minus 2 squared, 4. How about, let's say, another one? Let's do another. F of half. Where is half? Not here, not here. So half falls between 0 and 2. No? So then I have to use what? The second expression to find half. F of half. Function value at half. So it's going to be half plus 2 or 2.5. Right. Okay, so given a piecewise defined function, you should be able to find any function values, and you should also know how to graph a piecewise defined function, right? Then very important function. This is a very important function. You will get exam questions where you have to draw absolute value function graphs, right? So modulus or absolute value function, right? So first let's look at this symbol. This symbol is called modulus sign. Modulus sign or the absolute value sign. So this is how it works. Modulus of a, or the absolute value of a positive number, if you put a positive number inside, you just get the number back. It's 5. Let's suppose I put negative number. Then what happens is that number is multiplied by another negative sign. Then you get what? A positive 5. So absolute value means you always get the positive answer. So when it is negative 5, you multiply by a negative sign. So it becomes a positive value as the output. So this is how absolute value sign or modulus sign works, right? So now we generalize it into a function form. So instead of a number, you put the variable x. So then how can we define this? It has to be in two parts, no? When x is positive, what happens? Then it's just the value, no? Like in the example, if it is 5, you just get the answer as 5, no? So that is because inside value is positive. So if x is positive or equal to 0, you just answer is going to be x. Fx is just going to be equal to x. But what happens if it is negative 5? I want positive 5 as answer, no? So then the inside part I have to multiply by a minus sign to make it positive. So that is why when x is negative, what is the expression? Now x is negative, no? I want a positive answer, then I have to multiply by what? A minus sign. So the modulus function has two parts. It's a piecewise function. First part is for positive values, second part is for negative values. So what is the graph? First part or the positive part is what? Y equals x. That is what? Line, straight line through the origin. But we stop here for the positive parts. We don't draw it in this direction. Normally y equals x is that whole line, no? But we only draw it for the positive values. So we erase this. Then the negative, for negative values, x negative values, what is the function? Y equals minus x. This one. So that also has that function, that line also goes in this direction, but we only draw it for the negative values. So we erase the positive side. So that is how we get this V shape. It's a symmetric graph. Symmetric about y-axis. Right. So this graph is the absolute value function graph. Right. Okay. So then now we have discussed 4 types of functions and their graphs. Right. Now we want to modify these graphs. Modification is called transformations. So transformations means you modify the function to get different functions. Right. So first we are going to discuss 5 types of transformations. The first type is called vertical shifts. Right. So this is what is going to happen. So we are starting with a shape or functions graph we know. So suppose this is y equals fx. We start with that and we know the shape of that graph. Right. Or they will provide the graph. So here, this one we know. We know this is the shape of y equals fx. Right. Then what I am going to do is I want to draw y equals fx plus c. I just modified this by adding plus c to fx. So what will happen? So I added c. So I change what? Here I change the output. I added c to the output. So y values change, x values doesn't change. What will happen here? All the points in this graph, what is happening? Y values all go up by c units. No? So all points will shift up by c units. Every point in this black curve will go up by how many units? C units. So this blue curve is what? That is y equals fx plus c curve. So this is how you get y equals fx plus c if you know the shape of what? Y equals fx. What you need to do? You just need to move the black curve up by c units. That's all. Shape doesn't change. Everything just moves up. X values doesn't change. Only y values go up. Right. So that is what is mentioned here. To obtain fx plus c, we have to shift graph of y equals fx c units up. So then you can draw by yourself what happens when we subtract c. So again, this graph we know. The graph we know the shape of is also called parent graph. So this we know. Now I am modifying it like this. I am subtracting a c, fx minus c. Then what happens to each y value? Each y value go down by c units. So then I have to move this black curve down by c units. So same shape, but all the points move down by c units. Right. So that is how you obtain fx minus c. So this is what is mentioned here. To obtain fx minus c, you shift the graph of y equals fx by c units down. Right. So for example, we know this shape, no? Fx equals x squared. What is that shape? That is the parabola, right? Then how do I get fx equals not fx, let's say gx. How do I get gx equals x squared plus 1? So how did I modify x squared? This is the parent curve, the curve I know. I added plus 1. So all the y values should go up by what? Up by 1. So this vertex goes to 1. Shape doesn't change. So this is how you obtain what? Gx equals x squared plus 1. And let's say hx is what? X squared minus 1. So then what happens? It's like this second curve. You have to go down by 1 units. This parent curve. So now not 0, it will start at minus 1, the vertex. Shape doesn't change. So this is hx. So that is how you do vertical shifts, up or down. If it is plus c, go up. If it is minus c, go down. Right. Okay, then we discussed vertical shifts. Now horizontal shifts. Horizontal shifts means you change the input. That means only x values change, y values doesn't change. So here plus c or minus c is inside the function. So x is affected, not y. So that is why this goes left or right. So there's two cases, to the right shifts and to the left shifts. So let's see both cases. So again, I will start with the shape I know of, y equals fx. Right. Now I want to get y equals fx minus c. So here x is affected, not y. X, it's inside. C is inside. Okay. So that is going to be what? This is going to be, you move your curve to the right by c units. To the right by c units. So each point goes to the right by how many units? C units. Each point moves C units to the right. Right. So this type of transformation is obtained by what? Shifting y equals fx C units to the right. So then plus C you can obviously get no. Plus c means you have to move c units to the left. So let me draw that one also. Right. So again, we'll start with our parent curve y equals fx. Right. Now I want to draw fx plus c. So then I'm going to the left. So every point moves c units to the left hand side. Fx plus c. So this is the red curve. You move c units to the left hand side. Right. So then let's do a simple example. Again, we'll start with, we know this shape now. Fx equals x squared. Then we'll draw these two. Gx equals x minus 1 squared. This is what? This is actually f of x minus 1. No? If you substitute x minus 1 here, you get what? X minus 1 squared. And we'll also draw hx equals x plus 2 squared. That is what? That is f of x plus 2 squared. No? Sorry, f of x plus 2. If you substitute x plus 2 here, you get x plus 2 squared. So then this is the curve we know the shape of. Fx equals x squared. Then how do I get gx? Gx is what? You shift how many units? 1 unit to which side? Minus, no? Minus means to the right. And remember, you are shifting to the right. So y values doesn't change. X values change. So 0 goes to 1. And then just draw the shape. Same shape. So this is what? This is gx equals x minus 1 square. Right. Then the next one. hx what happens? Plus 2 inside. So that means 2 units to the left. So originally it's 0. No? So then 2 units mean minus 2. You are starting at minus 2 and going like that. So this is what? This is hx equals x plus 2 square. Right. So that is how you do horizontal shifts. Minus c means to the right, plus c means to the left. Right. So now we have done vertical shifts, horizontal shifts. Next is reflections. Right. So there's two types of reflections we are going to learn. Right. So the first type is reflection about x-axis. So this is the function y equals fx. Now I want to draw y equals minus fx. So how do I draw y equals minus fx? By reflecting y equals fx about x-axis. So think of x as a mirror and draw the mirror image. Okay. So that is how you reflect. So draw the mirror image. So here that is going to be y equals minus fx. Think of x as your mirror and draw the mirror image. So that's the reflection. Right. Then, The other type is a reflection about y-axis. So here, let's say my curve is like this. This is y equals fx. Then I want to draw y equals f of minus x. F of minus x. Minus is inside now, not outside. So then take y as your mirror and draw the mirror image. That is the reflection about y-axis. So you get what? This type of shape. No? So that is y equals f of minus x, right? Okay, so that is how you do reflections, right? So now we know uh, vertical shifts, horizontal shifts, reflections. Then uh, vertical stretching and shrinking is the next type, right? So let's look at that type now. So let's say, let's do a shape like this. Right, this is my y equals fx curve. Now I want to draw y equals a constant times fx, and here I'm going to take c to be greater than 1. Okay, remember this, constant is greater than 1. Okay, right. So what will happen here? Think, which values change, x or y? I multiplied the y, if function values by a constant, so y values change, x values are not affected here because c is outside. No, so then what happens to each y value? Each y value will be multiplied by this constant. So if it was 2, each y value doubles. If it is 3, each y value triples. So what is happening? Each y value is stretched by a factor of c. X values doesn't change, only the y values change. So you are going to stretch like this. Each y value stretches by a factor of c. If c was 2, each y value would have double. If c was 3, each y value would have triple, right? So for example, let's say this point was 2, then when it is c of fx, it's going to be what? Double 2c, c times that. If c was like 3, this would have been triple, 2 would have been triple to 6. That is what is happening. Y values are going to be stretched, right? Then that is stretching. Then vertical shrinking is the other case. So again, we'll start with this curve y equals fx. Now I want to draw y equals 1 over c fx. So c is greater than 1, so 1 over c is a fraction. So for example, this would be like what? This would be like, let's say y equals half x, where c is what? C is 2, no? Right. So y equals half x. So what happens to half of fx? What will happen to the function values now? Each function value will half. Each y value will be halved if c is 2, right? It's 1 over c, no? So now each y value shrinks. x values doesn't change. So you will get a shape like this. So a shrinking curve. So that is what happens when it is 1 over c fx, right? Okay, then we did vertical stretching, shrinking. Then the final type is horizontal stretching and shrinking. So what will happen? Now instead of c inside outside, c will be inside. So x values will be affected, not the y values. So that is called horizontal stretching and shrinking, right? So let's see how to obtain those. Right. So this one, right? So this is the curve given to us, the shape we know of. First one I want to do is, again c is greater than 1, remember that. I want to draw f of cx. So now it's inside, no, c is inside means x values will change, y values doesn't change. Okay, right, y values doesn't change. So now f of cx, then what happens? It shrinks by a factor of c. So if c is 2, if it is like f of 2x inside, each of the x points shrinks by a factor of 2. So half. They half. That is what is happening if it's like this, f of cx. Your graph will shrink in horizontal direction by a factor of c. So let's draw that. So what will happen? So the y values, the maximum and minimum point doesn't change. Those are same size. But the x values halves, or not half, shrinks by a factor of c. So in both directions, what happened? This black curve shrank. So this is how you obtain f of cx, right? Then the final type. Final type is what? Horizontal stretching. So then when inside is what? 1 over c times x. If it is like that, what happens? You stretch by a factor of c. So if it is half x inside, you stretch by what? A factor of 2. So you get a shape like this. It's stretched in both directions. So the black curve is stretched in both directions, right and left, by a factor of c, right? So those are the 5 types of transformations you need to know. So let's quickly summarize them. These two are what? plus c minus c. Fx plus c means shift up. Minus c means shift down. Then we learn what? Now plus or minus c is inside. If it is minus c, shift right. If it is plus c inside, shift left. Then we learn minus fx. If it is minus fx, it's a reflection x-axis. If it is f of minus x, minus inside, it's a reflection y-axis, right? So those are the first 6. Then we did what? We did cfx. Here c is greater than 1. What happens? You stretch by factor of c. If it is 1 over cfx, what happens? You shrink by a factor of c. Then the last two, those are what? Again, c is greater than 1. Now the c is inside. If it's cx, what happens? Shrink. Shrink horizontally by a factor of c. If it is f of 1 over c times x inside, you stretch. Horizontally by a factor of c. Right. So if you know these 10 transformations, you can draw a lot of curves. Right. So remember the types. Plus c minus c outside is up or down. Minus c plus c inside means left or right shift. Then the two reflections, minus fx, f of minus x. Then the vertical stretching when you multiply by a constant outside. When you multiply inside by a constant, it's a horizontal stretch or shrink, right? Okay, now let's do some examples. Right, let's look at this first exercise. Okay, so we want to draw first fx equals minus x, minus absolute value of x. So then what is the parent curve? Parent curve is the modulus curve. That one we know, no? This one we know. This is what? This is the graph of the modulus function. So what is the transformation applied here? You have multiplied it by a minus sign. So that is what? The outside multiplying by a negative. No? So then it's a reflection about x-axis. So then what is the correct curve then? You have to reflect this curve about x-axis. So then you get a downward V shape. So this is the curve for the first function. Fx equals minus absolute value of x is this one. That is the shape of the graph. Right. So here we had to apply transformations to get the correct curve. Right. So then second one, that is again what? What is the parent curve? Again the parent curve is what? The absolute value function curve. We have applied some kind of transformation to that. So recognize the transformation. What has happened? Minus 3 inside, not outside. If it is outside, you go up or down. But this is inside. Inside means what? Inside means it's minus means 3 units to the right. So we have to shift this absolute value curve 3 units to the right to get the curve of y equals absolute value of x minus 3. So what will happen? In the original curve it's 0, no? So now shift 3 units to the right, so that will become 3. Starting point is not the starting point, vertex is 3. Then the same shape, you just draw the V shape, right? So then there's a y-intercept, no? Let's quickly find the y-intercept. How do you find y-intercept? Set x equals 0 into the function and you get a y value, no? What is that value? 0 minus 3. So my modulus minus 3 is plus 3. So that is also 3, right? So this is the correct curve. Y equals modulus x minus 3 is this curve, right? So that is done. Now let's look at the third one. Fx equals x squared minus 2, right? Now for this one, what is the parent curve? Parent curve is what? X squared, no? You have modified x squared by subtracting 2. So here, this is the shape we are going to use to apply transformations. This curve, y equals x squared. So what is the transformation applied here? You have subtracted 2 outside. Outside means up or down. Because this is minus 2, what is happening? You are going down by 2 units. You are shifting down by 2 units. The curve of y equals x squared. So then keep the same shape. What happens? 0 goes to minus 2. The vertex goes down by 2 units. Minus 2, then the same shape. Parabola shape. Right. So that is the curve of what? Y fx equals x squared minus 2. So that was a vertical shift downwards, right? Then the last one. Okay. Last one is a special case. Let's look at that one. Y equals minus x plus 2 plus 3, right? So parent curve is obvious, no? It's absolute value function. What has happened here? There's not just one transformation, there are several transformations. There's what? Plus 2 inside. That plus 2 inside means what? To the left by 2 units. Then this minus sign outside means what? Outside minus means which reflection? X-axis reflection. Then this plus 3 outside is what? If you add something outside, that is up or down? Up. Plus 3, no? Plus 3 means up by 3 units. So 3 transformations are here. So you have to apply them all, right? So normally remember, vertical shift you apply at the last step. Okay, all the other transformations apply before this step. Keep the vertical shift as the last step. Okay, right? So then let's do this. Right, we start with what? our parent curve. Parent curve is what? Y equals modulus x, right? We'll first do what? We'll first do the reflection, the minus sign. So that will give you what? Let's do the x-axis reflection. So then what will happen? You have to just flip this curve, no, along the x-axis. So reflect. So then I obtain this one. This is what? This is y equals minus modulus x. So we have done the reflection. Then I'm going to do the horizontal shift to the left by 2 units. So that transformation I'm going to apply to this one. Now this is the function. Now I'm going to shift this 2 units to the left. Shift this 2 units left. So what do I obtain then? I obtain this becomes minus 2, right? What is this curve? Now two transformations are applied. Y equals minus x plus 2 modulus, right? So both of these are done. Now the last part. What is the last part? You have to shift everything up by 3 units. So this one goes up by 3 units. And wait, we'll find the y-intercept also for this one. What is the y-intercept? It's going to be minus 2, right? So everything shift up by how many units? 3 units to get the final shape. So 3 units up. So then what happens? This goes to minus 2 comma 3, and minus 2 goes to 1. So the y-intercept is 1. This is 3. This point is minus 2. So there is the final curve. We applied all 3 transformations and we got the final graph. So all 3 transformations are applied here. So this is how you draw a function where there is more than one transformation applied. Here 3 transformations were there. So we applied each of them and got the final curve. Right. Okay. Now let's look at another exercise. Right. So here this is the function. Function is given to us, right? And we have to draw these curves, right? So let's do the first one. So what is the transformation applied here? Minus 2 outside. So that means 2 units down. So this is the shape. No, I know this is the shape. So what happens? Each point goes down by 2 units. So minus 1 goes to minus 3. 0 goes to minus 2. 1 goes to minus 1. 2 goes to 0. 2 goes to 0. And 1 goes to minus 1. So let's draw that one quickly. So what happens? At minus 2, minus 1, 0, 1, 2, 3. So minus 1 will go to minus 3. So it will start at minus 3. then 0 goes to -2, so then 1 goes to -1, right? 1 goes to -1, and 2 will go down by 2 units to 0, right? So you have this shape, right? Let me draw it with a different color to make it clear, like that. Then 2 is also 0, no? Then that, and this 1 goes down by 2 units to -1, so like that, right? So that is how you get fx minus 2. Everything shift down by 2 units, right? What is the next one? Let's look at the next one. Second one is y equals f of x minus 2, right? 2 is inside. Then what values change? X or y? X is affected, no? It's inside, no? So you are shifting in which direction? Minus 2 means 2 units, right? So y values doesn't change. What happens? Minus 2 goes to 0. So now I am starting at 0 and ending at 5, right? Everything has to shift to right by 2 units. So let's draw that. So starting at 0, 0, -1, 0, -1, then -1 shifts to 1, 2, 3, 4, 5, right? So then just shift it like that. We'll get starting from here goes to 3, 4, right? This and same value as say 2, same here, right? So like that. So everything shifts to the right by 2 units. 2, 1, 0, -1, right? Y values doesn't change, but whole of this graph shifts to the right by 2 units, right? So then let's look at the third one. Okay. Third one, how many transformations? 2 transformations, right? Minus sign outside means what? X-axis. Plus this 2 outside means what? That means, so x-axis reflection. So this is 2 outside means stretch by what? Stretch by 2 units. Sorry, factor of 2. Factor of 2. So every y value has to be stretched by a factor of 2, right? So I will do this step by step. First I will do the x-axis reflection, then I will stretch it, right? So we have to reflect this now. Reflect this means you will get what? Let's see. Reflection. So it has to go through -1, like that, right? So this would be +1, -2, -1, 0, -1, minus 2, right? And these are 3, sorry, no, 1, 2, and 3, right? Okay, so now we reflected, no, now have to do what? Y value stretch by a factor of 2, right? So what's the only thing I have to change? X values doesn't change, no. Each Y value will, what happened to each Y value? It's going to be stretched by a factor of 2. So it's not going to be minus 2. It's going to be minus 4. This is going to be not minus 1, double it. Minus 2. 0 can't double, no. 0 times 2 is just 0. 1 is going to be what? 2. So that is the curve there. 2, 0, minus 2, minus 4. Everything stretched by a factor of 2 and reflected. So that is y equals minus 2fx, right? Then we'll do the last one. The last one also has two transformations. So fourth one is what? Y equals f of 1/3 x inside plus 1, right? So what are these two transformations? 1/3 means what? 1/3 inside, no? So then horizontally stretch, right? Horizontally stretched by what? By a factor of 3, and plus 1 outside means what? Up by 1 unit, right? So this one, let's first do the stretching, then we'll shift it up by 1 unit, right? So stretching horizontally, no, so y values doesn't change, x values change. So what happens? 3 goes to stretch by 3 units. 3 times 3, 3 goes to 9, 2 goes to 6, 1 goes to 3. 0 times 3 is 0, no? So 0 is 0. Minus 1 goes to minus 3, minus 2 goes to minus 6. Is that clear? Every x coordinate stretches by how many units? Uh, stretches by a factor of 3 units. So you multiply by 3. 3 times 3, 9. 2 times 3, 6. 1 times 3, 3. Minus 1 times 3, minus 3. And minus 6. Y values doesn't change, right? So that is the horizontal stretching part. So you get minus 6, minus 3, plus 3, plus 6, plus 9. And the y values doesn't change. Minus 1, 0, 1, 2. Those doesn't change. Minus 1, 0, 1, 2. Those doesn't change for the stretching part only. Okay. So we are first doing the stretching part. So start from here. Have to go to there, right? Then you go from there 2 to 3 to 6 like that. Then 3 to 9 like that, right? So this is what? This is y equals f of 1/3 x, right? So stretching part is done. Now you have to do what? Now we have to shift everything up by 1 units. So what happens to this point? Not minus 1, it goes to 0. 0 goes to 1, 1 goes to 2, 2 goes to 3, right? So I will draw that curve here. So it's easy, this will go to here, this will go to 1 will go to 2, 2 will go to 3. This will go to 3, and this is going to be again this. So this red curve is what? Red curve is the final answer. Y equals f of 1/3 x plus 1. So that is the correct curve. We horizontally stretched and then shifted this up by 1 unit, right? So that is how you apply transformations to get function curves, right? Okay, now the last topic in this third part. This is a new type of function. This is called composite functions, right? Composite functions, you can think of it as a function inside of another function. Okay, so you have to have two functions, f and g. This notation f circle g is called composition of f and g. Okay, this is the composite function of f and g. So this is read as f circle g, right? So in this form, there's two functions. It's a function inside of a function. So the left one is the left function, f is the outer function, right hand side function is the inner function. So g is inside of f. Okay, this is how you write this. F circle g is f g of x. So g is the inner function. Then similarly we can define other composite functions. So now g circle f. So g is the outer function, f is inside of g. Then f circle f. So f is the outer and the f is the inner also here. Then g circle g means g is the outer and the g is the inner function itself, right? So quick example, let's say fx is x squared and gx is x plus 1, right? So then what is g circle f? This is a composition between g and f, no? So write it using the definition. What is the inner function? Fx. So g of fx. So fx is inside of g. So just write fx. What is the fx expression? X squared. So you are trying to find g of x squared. So that is what? X squared plus 1. So that is how you find what? A composite function. Similarly, you can do what? F circle g. So here, what is the inner function? G of x. Outer is f. So g is inside of f. So what is g? X plus 1. So we are trying to find what? F of x plus 1. So wherever you see x in function f, substitute x plus 1. So what is the function? X plus 1 square. So this is how you get composite functions. So they are, just think of it as a function inside of function. Identify the inner function. Then write out the expression and simplify. That's all, right? So we'll do an example for that and finish this section, right? Okay, we want to find what? We are given two functions, x squared and gx is x minus 2, and we want to find all four of these composite functions. So first, f circle g, that is what? F of gx. So gx is the inner function, f is the outer function. So now what is g of x? X minus 2. Put it inside. That's all. So then I want to find what? F of x minus 2 expression. So wherever I see a x in fx, I have to substitute x minus 2. So what do I get? X minus 2 squared. Or if you want, you can expand this. X squared minus 4x plus 4. Right. Then let's do the next one. Same concept. G circle f means g is the outer function, f is the inner function. So now write the inner function. What is the inner function? X squared, right? Substitute. So g of x squared. Wherever I see a x in g, I have to substitute x squared. So this is the new composite function, x squared minus 2, right? Then the third one, what is third one? F circle f, right? So now the outer function and inner function both are f, right? So now substitute f. What is f? X squared. So I'm trying to find f of x squared. What is that going to be? X squared squared, right? I'm substituting x squared wherever I see x, no? So then x squared squared. So that becomes x to the fourth, right? Let's do the last part. G circle g. Then g of gx. So inner and outer are both g. What is g? X minus 2. So I am trying to find g of x minus 2. So wherever you see a x in this function, I have to substitute x minus 2. So for x, I have to substitute x minus 2. So I get what? X minus 2 minus 2. So instead of x, I have to write what? X minus 2. And now simplify x minus 4, right? So that is how you do composite functions, right? Okay. So that is the third part of the algebra lesson series. In the next part, I'm going to discuss polynomials and long division, right? So see you guys in the next lesson.